In 1961, John F. Kennedy signed off on a power line that would run from a converter station on the Columbia River in Oregon all the way down to Los Angeles. Crews finished it in 1970. 846 miles of direct current at 400,000 volts, enough to serve up to 3 million Los Angeles households, and at the time, the longest line of its kind anywhere on Earth. But 56 years later, it is still the longest America has. Meanwhile, China took that same idea and pushed it to nearly 3 times the voltage, and in the 2020s alone, finished more than 8,200 miles of it. In that same time period, the United States finished just 375. So how did the country that once led this fall so far behind? What do those Chinese wires actually carry? And can America still catch up? The thing China built has a name: ultra-high voltage transmission. But strip the jargon off, and what is left is wire, strung between steel towers, running for thousands of miles, carrying electricity at pressures high enough to jump across open air. Nobody campaigns for wire. That is most of the reason this gap opened. Let's start with the physics, because the whole thing sits on one inconvenient fact. Electricity does not travel for free. Push it down a wire, and some of it turns into heat and leaks into the air, and the further you push, the more you lose. That is tolerable when the power station sits 30 miles from the city. It becomes the whole problem when your sunshine is in a desert and your factories are on a coast 2,000 miles away. Here's the key idea. The heat loss comes from the current, not from the amount of power you are sending. Raise the voltage, and you can move the same electricity with far less current, and the losses collapse. Think of it like a delivery route. It is the number of trucks that grinds up the road, not the weight of the cargo. So you send fewer trucks, carrying more each. Voltage is how you make the trucks bigger. That is all high voltage means. Not a different kind of electricity, just an enormous amount of pressure behind it. So if higher voltage fixes the losses, why is any of this hard? Because there is a second choice stacked on top. Alternating current is what runs your house, and what nearly every grid on Earth is built from, because a transformer steps it up and down cheaply. Over long distances though, alternating current bleeds energy in ways direct current does not, and it needs the grids at both ends to stay perfectly in step. Direct current does not negotiate, it just pushes. The catch is the ends. Direct current cannot go straight into your wall socket, so it needs a converter station at each terminal, a hall full of transformers and switching valves that costs hundreds of millions of dollars before a single mile of wire goes up. So the arithmetic only works past a few hundred miles. Below that, the converters are a waste of money. Above it, direct current wins, and the longer the line, the more it wins by. Which brings us back to the number in the intro. Engineers draw the ultra-high voltage line at 800,000 volts. Below that is high voltage, and that is what the Pacific intertie has always been. 400,000 volts when it opened in 1970, 500,000 after an uprate in the mid-80s, and it has not moved since. It was the longest line of its kind on Earth. It was never in the ultra-high voltage class. Neither is anything else America has ever built. That is the real shape of 8,200 against 375. America did not build fewer of these lines than China. America has never built one at all. So what does 8,200 miles of it look like on the ground? It starts at Changji in Xinjiang, where a converter station sits out in scrub desert and a line leaves it heading east. It does not stop for 2,046 miles. It ends at Guquan in Anhui province, on the edge of the Eastern Industrial Belt. It runs at 1,100,000 volts, the highest transmission voltage ever built anywhere, and it carries 12,000 megawatts, roughly the output of 12 large power stations, on a single line. To put that in context, moving that much power that far would be pointless if the losses ate it on the way. They do not. State Grid puts the line's losses at about 1.5% per 620 miles. Over the full run, roughly 95% of what goes in at the desert end comes out the other. That number is the entire reason the strategy works. And it is not one line. As of late 2025, China had 45 ultra-high voltage projects in operation, a mix of alternating and direct current, totaling more than 25,000 miles of wire. Here's where it gets complicated. Changji to Guquan opened in 2019. This was never a 5-year sprint. It is a program that started in 2009 and has not stopped since, running through 3 consecutive 5-year plans, with one owner making the decisions and one set of hands signing the permits. Which raises the obvious question. America has deserts, it has wind, it has the money. Why has it built almost none of this? The answer is not technology, and this is the part that matters. America has always had access to the engineering, and it never had to invent any of it. The Pacific Interties converters were contracted in 1965 to a joint venture of General Electric and ASEA, the Swedish company that later became part of ABB. Decades later, ABB and Siemens supplied the converter equipment for Changji to Guquan. The same vendors sold to both countries, but only one of them kept buying. The answer is, who holds the pen? In the United States, the Federal Energy Regulatory Commission has authority over interstate transmission planning and over how the costs get divided up. It does not have the authority to site the line. Siting, meaning the right to stand a tower on a specific piece of ground, is left almost entirely to the individual states. A federal appeals court confirmed the limit directly. If a state denies a siting request, FERC cannot overrule it. So a line crossing 4 states needs 4 separate state approvals, and each state commission asks one question. Do our ratepayers benefit? Not, does the country benefit? A state in the middle of a route, the one that gets the towers and none of the electricity, has every reason to refuse, and the law hands it the standing to do it. That single design choice explains the 375. In 2023, the United States added 55 miles of transmission at 345 kilovolts or above. In the early 2010s, the annual average was around 1,700 miles. Meanwhile, more than 2.2 million megawatts of generation, twice the capacity of the entire American power system, sits waiting in interconnection queues for wires that were never built. Utilities respond rationally. Long interstate lines are slow, litigated, and jurisdictionally hostile. Short local upgrades inside your own territory are fast and earn a guaranteed return. So that is what gets built. In the Mid-Atlantic, spending on small local projects rose 26-fold between 2009 and 2023. The money is being spent. It is going into short lines instead of long ones. What happens when someone actually tries? Watch Grain Belt Express. It is an 800-mile direct current line designed to carry 5,000 megawatts of Kansas wind east across Missouri and Illinois into Indiana, connecting 4 separate grid regions for the first time in American history. Cost $11 billion. Invenergy first proposed it in 2010. 16 years later, it has not been built. The line spent those years in state commissions and courtrooms. Missouri regulators rejected it repeatedly before approving it. A Missouri county tried to block it by refusing permission to cross county roads and lost on appeal. In July 2025, the federal government cancelled a $4.9 billion loan guarantee approved 8 months earlier, after a senator publicly called the project a scam. Invenergy said it would build with private money instead. In January 2026, the Illinois Supreme Court threw out a farmer's challenge to the state permit, 6 votes to nothing. Construction on the first phase, Kansas to Missouri, is due to begin this year. Set the clocks side by side. Grain Belt Express has taken 16 years to reach a groundbreaking, and it is a high-voltage line, not an ultra-high voltage one. Changji to Guquan took about 3 years to build, and China has 44 more projects like it already running. And notice what is absent. Nobody argued the line would not work. Not one of those fights was about physics. Every one was about land, jurisdiction, and who pays. So China won on wires. Does that mean it won on clean energy? Here is where the story stops flattering anybody. A great deal of what moves along those ultra-high voltage lines is coal. The Megabase model bundles desert, wind, and solar together with new coal capacity at the sending end, so the line has something steady to carry when the weather stops cooperating. Planning rules for the last 5-year period required renewables to make up no less than half the mix of hydro, wind, solar, and coal on these corridors. But that is an average, and averages can be gamed. Dedicated hydropower lines run at 100% clean and pull the number up, leaving room for other lines to run mostly on coal and still hit the target. Look forward and it tightens. By 2030, China's wind and solar megabases are projected to reach around 455 gigawatts, roughly equal to all the utility-scale wind and solar installed across the entire Americas as of early 2026. 315 gigawatts of that is planned to travel east on ultra-high voltage lines. Under current planning assumptions, delivering it would require about 104 gigawatts of new coal at the sending end. That is 8% of China's operating coal fleet, built to make the clean lines work. And the strongest version of the case against everything you have just heard comes from the analysts at Korea, who argue the wires are not the binding constraint anymore. In the first quarter of 2026, by their calculation, Chinese wind and solar could have produced around 170 terawatt-hours more if the existing capacity had been used at the previous year's rate. That is more than 4 months of China's entire nuclear output thrown away. Their diagnosis was not a shortage of grid. It was coal plants locked into long-term contracts that guarantee them fixed output at fixed prices, leaving them no reason to step aside. Provincial power is traded on annual contracts, so wind from Inner Mongolia cannot be redirected to Guangdong on a Tuesday, even when the copper to do it is sitting right there. Wires are necessary. They were never sufficient. The waste is rising in both countries, and the numbers are not small. In the first half of 2025, Chinese wind and solar curtailment roughly doubled year on year to around 6% nationally. The national figure hides where it hurts. Tibet curtailed about 30% of its wind, up from just over 2% a year earlier, and about 34% of its solar. Qinghai threw away 15% of its sunshine. China's coal fleet now runs at roughly 48% utilization, the lowest on record, because it is held as insurance rather than run as a workhorse. America wastes power too, for the blunter reason. California's grid operator curtailed more than 738,000 megawatt-hours of wind and solar in the first 4 months of 2025 alone. Kansas wind blows across ground with no line to carry it anywhere. Same physical waste, different failure. China built the wires and kept the wrong dispatch rules. America has neither. Which brings us to the clock, and it is running now. State Grid plans to spend 4 trillion yuan, about $574 billion, on fixed assets between 2026 and 2030. That is 40% more than it spent in the previous 5 years, and it targets a 30% increase in cross-regional transfer capacity from where it stood at the end of 2025. America's answer, so far, is one 800-mile line breaking ground 16 years after it was proposed, and a stack of bills in Congress that would hand FERC siting authority over interstate lines. None has passed. Back at the Dalles, the Celilo converter station is still running. It has been rebuilt and upgraded again and again since 1970, its capacity creeping from 1,440 megawatts to 3,800. It works. It has always worked. America proved the idea was sound 56 years ago, then spent the next half-century deciding it was too hard to do a second time, while the country that borrowed the blueprint turned it into a national program. The panels were never the hard part. The permission was.